Hello students, welcome to my new video. So today we are going to do the second part of the video from free body diagrams of class 11, okay, from the chapter of Newton's laws of motion. Those who have not seen my previous video, please go and watch my previous video where we have discussed about the first part. I have discussed about the first few bodies over there, few examples over there, and I have also told you what are basically free body diagrams and how to solve them and how to find out the acceleration in these cases. Okay, over here we are going to discuss about few more important free body diagrams. Fine. Okay, so let's start. Number one, the first one is okay. If there is a surface, and in the surface if I place two bodies which are in contact with each other, okay, in a surface, suppose there are two bodies which are in contact with each other and I am applying a force from one direction and there is an acceleration on both the bodies, okay, in that case how to find out the acceleration? So see, motion of two bodies placed in contact. So motion of two bodies placed in contact. Okay. So this is the scenario. So this is one body. This is one more body. This is one more body. Fine. This is suppose M1. This is M2. I am applying a force in this direction. Which is producing an acceleration in both the bodies along this direction. Right? Okay. At first, we have to draw the free body diagrams. Okay. Now see, when I am applying force in this particular body, this body is going to push this body. Okay. This body is going to push this body. Suppose this body is pushing this body with a force F, small f. Okay. Not necessarily if I give a force capital F to this body, this one also will push this body with the same force. Might not happen. Okay. So this body is going to push this body with this particular force small f. Now, when this body is pushing this body with this force small f, this is also going to push back this body with the same force. Because we know action and reaction, okay, they are always equal and opposite to each other. So these are like action and reaction, Newton's third law of motion. If this is action, this is reaction, or if I consider this is action, this is reaction. Fine. So if this body is going to push this body will say, you are pushing me, I will also push you with the same force. Okay. No matter the size. Remember, size does not matter in action and reaction. Remember this one. Size does not matter in action and reaction. In action and reaction, or according to Newton's third law, everyone is same. No, if this body is a small body, this body is a large body, as you can see. But if this one pushes this one with a force, this one also will push this one with the same force. Same force is going to act. Fine. Okay. Now see Newton's in these free body diagrams. In the previous video we have seen that only one body was there. But now we will see if multiple bodies are there. So if multiple bodies are there, then a very good way to solve is to draw the bodies separately. Okay, always draw the bodies separately and mark the forces in the bodies separately. Okay, so how to see this? This is one body. This is one body, first body. Okay, this body's mass is m1. This body's mass is m1. Fine. Now see, what are the forces that are acting on the body? What are the forces? This is force. This force I am giving F. One force will be acting in this direction, that is M1G. One will be reaction force, that is R1. Okay, this one will be the reaction force. This small f is acting in this direction. This is small f which is acting in this direction. Right? And the body is having an acceleration in this direction. So these are all the forces that are acting on the body. What about the second body? This second body. This is your second body. Mass M2. Okay. So this one will be M2G. This one will be R2. Okay. Now over here, I will not put this capital F force. Why? Because this in capital F, this force is acting on this body. this force I have given to this body. I have not given to this body. This force I have given to this body. So this force I will mark only over here. Over here I am not going to mark this capital F. Fine? Okay. So what are the forces that are acting on this body? One is this small f. So small f is acting in this direction. Just see your main diagram and just read. Okay. So only this force is acting in this direction. Only this small f is acting in this direction. Now this small f is a result of this capital F. Since this capital F is acting, that is why this body is pushing this body with a force small f. Okay. So only this force small f I will be showing over here. Whenever you are drawing two bodies separately, always mark the forces which are acting on that particular body. So this one also will be having an acceleration in this direction. Okay. So how to solve this? First, let us take this body for M1. For M1. Okay. Now see, vertical forces, obviously there is no motion in the vertical direction. In the previous video I explained to you nicely. If there is no motion in the vertical direction, that means these two forces are getting balanced. Okay. So I can write R1 equals to M1G. R1 equals to M1G. Fine. In the horizontal direction, you see F is acting, small f is acting. Okay, capital F is acting, small f is acting. Now, which one is greater? Which one is greater? The body is having a movement in this direction. Okay, the body is having a movement in this direction. So, of course, this one has to be greater. This one has to be greater. So, what is the resultant force which is acting on the body? The resultant force is capital F minus small f. Why capital F minus small f? Because capital F is greater, has to be greater, because as I said, the body is moving in this direction. Fine. So capital F minus small f. This is the resultant force which is acting on the body. Now this resultant force will be equal to mass into acceleration. M1 into. This is equation 2. Okay. Let's see for M2. For M2. For M2 again, these are the vertical forces which will be balanced. R2 will be equals to M2G. R2 will be equals to M2G. Equation 3. In the horizontal direction, you see there is only one force. Only one force is there, that is small f. So I can write small f equals to M2 into A. This is the small f. Okay? Equation 4. Now remember our task was to find out the acceleration. So how to find out the acceleration? Use this equation 4 in equation 2. Put this value of f over here. Okay. So putting equation 4 in 2. Putting equation 4 in 2. Okay. So I will get capital F minus f. Small f is m2a. That is equals to m1. Now if I solve this one, I will get m1a plus m2a will be equals to f. So a will be equals to m1 plus m2. A into m1 plus m2 equals to f. So a will be equals to f divided by m1 plus m2. So this is our acceleration. This is our acceleration, okay, for both the bodies. Remember one thing. Since both the bodies are attached to, that means they are just placed in contact with each other. They are placed in contact with each other, and I am considering that these two bodies are moving together. Okay, these two bodies are not moving separately. Remember this one. If these two bodies are moving separately, then this body and this body will be having different acceleration. But I am over here, I am not considering that one. I am considering the two bodies are placed in contact and I am pushing the body, and the two bodies are moving together only. They are together in contact, they are moving in contact only. They are not getting separated. So in that case, the acceleration of this body is going to be the acceleration of this body. Both the bodies will be having the same accelerations. Okay? So this is the acceleration. What about the contact forces? The contact force. This small f and f, these two are known as the contact forces. Okay? These two are known as the contact forces. These two are known as the contact forces. So how to find out the contact force? You can find out from the equation 4. From equation 4. small f is equal to m2 into a. Just put down the value of a. So I will get f into m2 divided by m1 plus m2. So this is going to be the contact force. Okay, this is going to be the contact force. So this is how we can find out the acceleration and the contact force if two bodies are placed in contact and you are applying the force from one direction. Okay, now what is going to happen if you are applying the force in this body? Okay. Suppose I am applying the force in this body, but I can also apply the force in this body. Suppose this is the body, this is the larger body, m1, m2, and suppose I am applying the force in this body. Okay, then acceleration will be in this direction. In that case, what is going to happen? In that case, what is going to happen? Remember, students, in that case, if you solve it in the same way, you have to solve it in the same way. This will be f, this will be f. If you solve it in the same way, you will see the acceleration is not going to change. Acceleration is going to remain the same, f divided by m1 plus m2. Acceleration will remain the same, but the contact force is going to change. Contact force is going to change. Contact force in this case is going to be f m1 divided by m1 plus m2. Okay, this is going to be the contact force. Contact force is going to change because you see over here, the smaller body was pushing the larger body, but over here the larger body was pushing the smaller body. Will be pushing the smaller body. Okay, so the contact force is going to change over here. Fine. Okay, so this is how to solve if two bodies are placed in contact. Next one. Number 2 is if two bodies are connected by a string. This is also very important. If two bodies are connected by a string, okay, if two bodies are connected by a string, you know, students, whenever there is a string attached to a body, then there is one more force that you have to take, that is known as the tension force. The tension force. See over here. Suppose this is a horizontal smooth surface. This is M1. This is M1. Okay. Over here, I have connected a string with which one more body is attached. This is M2. Okay. And in this direction, I am applying a force F. In this direction, I am applying a force F. Fine. Now, in this case, what should we use? So first, you have to mark first we will mark all the forces that are acting on the body. Okay. Now see, if I pull this force, this is the string which is attached, which is connected between both the bodies. Okay. So this body is going to pull this body. Okay. If I pull this body from this side, this body is going to pull this body. So tension will be acting in this direction. This will be the tension. Okay. Also, this body M1 is also going to pull the body, is going to hold the body in the back, in the backward direction. M2 is going to pull, M2 will try to pull the body in the forward direction, but M1 will also try to resist that, isn't it? M2 is going to pull the body in the forward direction, so one tension will be acting. But M1 is also going to resist that particular force. So one more tension will be acting, but that will be the same tension in this direction. Okay, so T and T. So this particular rope will be straight like this between the two bodies. This particular rope will be straight. Remember, students, why these two tensions will be acting? This body is going to pull this body. So one force will be acting over here on this tension. That is this tension T. Also, this M1 is going to resist that one, because M1 will not try. First, it will not try to go along with M2. So this will try to resist that force. So one tension will be also acting in this direction. Okay, so M2 will pull M1 in the same way. M1 is also going to resist in this direction. So a tension will be acting in this direction. Fine. Okay. Now, if I draw the bodies separately, okay, and acceleration will be in this direction. Acceleration will be in this direction. Remember, this body and this body, they will be moving with the same acceleration. Acceleration of this one is A, acceleration of this one also is A, and the acceleration of the entire system is also A. Why? Because both the bodies are connected together. They are connected bodies, both the bodies are connected together, and this string is also straight over here. They will not move in this way that M2 will go a long distance, then afterwards, after some time, M1 will start moving, not like that. When I will be applying the force, M2 will be moving, and along with that, M1 also will be coming. So both the bodies, they will be moving with the same acceleration. Okay. Now first I will draw the bodies separately. So, this is your M1. What are the forces that are acting? This will be M1G. Over here you see we have no use of the vertical forces because we know vertically the bodies are not moving. Still I am marking over here. And this is your tension. This one is your tension. This is your first one. For the second one, this is my M2. This is M2G. This is your R2. Fine. So this is F, and over in this direction there is one tension T, and there is an acceleration A in this direction. There is an acceleration A in this direction. Fine. Now how to solve this? For M1. Okay. So number one, vertical forces will be balanced. So R1 will be equals to M1G. These are the vertical forces. In the horizontal direction, you see there is only one force, that is T. So T will be equals to mass into acceleration. So T will be equals to M1 into A. This is your equation 1. Fine. Let us go to second body for M2. For M2. You see for M2, again in the vertical direction, R2 will be equals to M2G. R2 will be equals to M2G. In the horizontal direction, two forces are acting. One is force F, one is tension T. Now, which one is greater? Which one is greater? Force F is greater because the bodies are moving in this direction. So, force F will be greater. So, what is the resultant force? Resultant force is F minus T. That is, of course, equal to mass into acceleration. So, M2 into A. Okay. Now this value of T we can put over here. Suppose this is equation 2. So putting 1 into. Remember our task was to find out the acceleration. So putting 1 into, I can write F minus M1A equals to M2. So M1A plus M2A will be F. So M1 plus M2 will be equals to F. So acceleration is going to be F divided by M1 plus M2. This will be the acceleration. So this will be the acceleration. So F divided by M1 plus M2. If I want to find out the tension in this one. Tension. So just see equation 1 we can use. Using 1, T will be equals to M1 into A, that is M1F divided by M1 plus M2. This will be the tension. Okay, M1F divided by M1 plus M2. Okay. If I had applied the force in this body, suppose this was the block, these were the blocks M1, M2, so tension, but if I had applied the force in this body, in that case, what would have been acceleration? Acceleration would have been same, acceleration will be same, F divided by M1 plus M2. But in that case, tension will be different, that one will be M2F divided by M1 plus M2. Okay, M2F divided by M1 plus M2. Okay. So I hope you have understood this one. Number 3. Now we are going to use pulleys. Okay. Now we are going to use pulleys. Okay. So number 3 is two bodies connected by a string and passing over a fixed pulley. Two bodies connected by a string and passing over a fixed pulley. Now this pulley is smooth pulley. That means I am not considering any friction. This is a smooth pulley. That means I am not considering any friction. So this is the pulley suppose. These are the two bodies. Here is one body. Here is one body. These are the two bodies. This is suppose M1. This is suppose M2. Okay. Now, over here, if M1 is equal to M2, then we know that the pulley will stay in equilibrium. But if M1 is greater than M2, in that case, what is going to happen? In that case, this M1 is going to come down with an acceleration. This M1 is going to come down with an acceleration, and M2 is going to go up with the same acceleration. Okay, M2 is going to go up with the same acceleration. What are the forces that are acting on the body? This one will be M1G. This one will be M2G. Right? Now see, this pulley is holding this M1 in the upward direction. Okay, this pulley is basically holding this M1 in the upward direction. So of course, one force tension will be acting over here, and the same tension is going to act over here because this pulley is also holding this block in the upward direction. So tension, both these tensions will be acting over here. Remember, tension force is being applied by whom? Tension force is being applied by this particular support, the rigid support. Many students think that the rope exerts the tension force. Basically, the rope does not exert the tension force. The support exerts the tension force, and the tension force acts through the rope. Okay, the tension force acts through the rope. The support is the one which is pulling the body in the upward direction, which is holding the body in the upward direction. So the support is the one who is responsible for exerting the tension force. Okay, and the tension force is acting through the ropes. Okay. Now if I draw these two bodies separately, see first M2. This is your M2. What are the forces that are acting? See, M2G is acting. Okay. Over here tension is acting, and this is the acceleration. M1 for M1. This is M1. M1 is acting. M1G is acting. In this direction, tension is acting, and this body is going the downward direction. A. Right. Okay. Now let us do first we'll do for M1. Okay. For M1. What are the forces that are acting on this particular body? T is acting, M1G is acting. Which is greater? You see, this body is coming down. So since this body is coming down, M1G must be greater than tension. M1G must be greater than tension. So resultant force is M1G minus T. So M1G minus T will be equals to mass into acceleration. Right? From here, let us find out T. T will be M1G minus M1A. This is your equation. Let us see for this body, for M2. For M2, you see, M2G is acting, T is acting. Which is greater? T is greater because this body is moving up. So T is greater than M2G. So the resultant force is going to be T minus M2G. That is going to be the resultant force. So T minus M2G will be equals to M2. From here also you find out T. That is M2G plus M2A. This is your equation 2. Now see, this is also T. we can equate these two, we can make these two equal. So therefore we can write m1g minus m1a equals to m2g plus m2a. So from here we will solve and find out the value of a. So we can bring all the a's to one side. So m1a plus m2a will be equals to m1g minus m2g. So a m1 plus m2 will be equals to g m1 minus m2. So from here we will get a will be equals to m1 minus m2 by m1 plus m2 multiplied by g. This is your acceleration. Okay, so this one is our acceleration. But if I want, I can find out the tension also. Let us find out the tension. Any one equation we can use, either equation 1 or equation 2. So using equation 1. So tension is equal to m1g minus m1a. That is equals to m1g minus m1 into a. m1 minus m2 by m1 plus m2 into g. Okay. So what we can do, m1g we can take common, 1 minus m1 minus m2 by m1 plus m2. So m1g m1 plus m2 minus m1 plus m2 divided by m1 plus m2. So we will left with 2m1 m2g divided by m1 plus m2. This is your tension. This one is your tension. Okay, 2m1 m2g divided by m1 plus m2. So this is how we can solve if two bodies are connected by a string and they are placed over a smooth pulley. Right? Next we will see if three bodies are connected. If three bodies are connected with two strings and they are passing over a pulley, in that case what to do? If three bodies are connected by two strings, okay, and passing over a okay. So the diagram will be somewhat like this. This is your rigid support. This is the pulley. Okay. This is our one block. This is our first block. Right. So this is our first block. Suppose this one is M1. M1. Here I have connected one more block. That is M2. And here I have connected one more string. Here I have connected one more string with which I have connected one more block. That is M3. Now in this case, what is going to happen? In this case, what is going to happen? You see. Now over here, you see there are two strings. One string is this one, and here also I have connected one string. There are two strings basically. So first, let us mark the forces which are acting on these bodies. So one more thing, and over here let us assume that M2 and M3, M2 plus M3, the weight of M2 plus M3 is greater than M1. Okay, so the body will be accelerating in this direction, and this one will be moving up. Okay, the body will be accelerating in this direction. This one is going to move up. First, let us mark the forces. This one will be M1G. This is going to be M1G. Over here, let us first mark the weights. These two will be M2G and this one will be M3G. Okay. Now the tensions. This support is going to pull these bodies up, so T and T. This support is going to pull these two bodies in the upward direction with the same tension, T and T. Okay, so T and T. Or we can mark this one as T1 and T1, since there will be one more tension over here. Over here you see this body M2 is also holding this body M3. This M3 is actually being held by this body. So M2 is this body, M2 is pulling up this M3. So in this direction one tension will be acting, that is T2. That is T2. Okay? And this M3, this is also exerting a force in the downward direction. So this M3 is also pulling this body M2 in the downward direction. So in this direction also the same tension will be acting T2. Okay, those who didn't understand, here I am drawing once again this M2. Here there is a string, this is M3. Okay, let's see, the entire weight is acting in the downward direction. The entire weight is acting in the downward direction. So first of all, M2 is holding this M3 because it is M2's responsibility to hold M3. Otherwise, this will tear and M3 will go down, it will fall down. So M2 is holding this M3. So one tension will be acting in this direction. Okay. Also, since the weight of M3 is acting in this particular, the downward direction, M3 is also pulling M2 in the downward direction. Okay. M3 is pulling M2 in the downward direction also. So one force will be acting in this direction. So these are the two tensions which are acting on the string. So T2 and T2. Okay. Now if I draw the body separately, okay. This is our one body N1 where I am drawing. So this is our body M1. So M1, what are the forces? M1G, and here we have P1, and this is the acceleration. Okay, this is the acceleration. Second body M2. So for M2 we have M2G, we have T2, and we have in this direction T1, and we have the acceleration in the downward direction. Okay. For the third body M3, we have M3G, and we have T2 in this direction. Okay, and this is also coming in the downward direction. So these are the free body diagrams of all the three bodies individually. Always students, whenever you are getting something complicated, always try to solve, always try to draw the body separately and mark the forces. Okay. Now we are going to find out the equations, and then we are going to find out the acceleration. Even our main task is to find out the acceleration. Okay. So for M1, first we are going for M1. For M1, so this is going up. So T1 must be greater. So resultant force is T1 minus M1G. So T1 minus M1G, that is equals to mass into acceleration. Fine. So from here let us find out T1. So T1 will be M1A plus M1G. Equation 1. Now let us go to mass, the second body for M2. Okay. Now M2, you see, these two forces are acting in the downward direction. This force is acting in the upward direction. The body is going down. M2 is going down. So of course these two, the resultant of these two. Okay. So this one plus this one must be greater than T1. Okay. This one plus this one must be greater than T1. Since the body is going down. So the resultant force is going to be this. This is the resultant force. M2G plus T2 minus T1. This is the resultant force. This one has to be greater because this body is going down. So this one has to be greater. So resultant force is M2G plus T2 minus T. That is equals to mass into acceleration. Okay. We can remove the bracket and write in this way. M2G plus T2 minus T1 equals to M2. Okay. So this is our second equation. Let us take the third body for M3. Now for M3 you see, again this body is going down. So the resultant force will be M3G minus T2 because it is going down. So M3G is greater. So M3G minus T2. So M3G minus T2, that will be equals to mass into acceleration. From here I can find out T2 will be equals to M3G minus M3. This is your third equation. So see, these are the three equations that we are getting. These are the three equations that we are getting. Our task is to find out the acceleration. So how to find out the acceleration? Put this equation 1 and equation 3 in this equation, equation 2. Okay, let us solve. Putting 1 and 3 in 2. So I am putting 1 and 3 in 2 in equation 2. So I will get M2G plus I have T2. So T2 is this one, M3G minus M3A, okay, minus T1, that is minus M1A minus M1G, that is that is equals to our M2A. Now bring all the A's to one side, okay, and all the other terms to the other side. So this one I am putting here, this one I am putting here, okay. So M2A plus M1A plus M3A equals to M2G plus M3G minus M1G. Okay, minus M1G. I can take A common. So M1 plus M2 plus M3, that is equals to, I can take G common. So M2 plus M3 minus M1. Okay, so our acceleration is going to be M2 plus M3 minus M1 divided by M1 plus M2 plus M3 multiplied by G. This is going to be our acceleration. Okay, so in this case, this is going to be our acceleration. How to find out the tensions? Okay, how to find out the tension? Suppose I want to find out T1. I want to find out T1. So T1 will be equals to M1A. So if I do M1A, okay, just see, if I do M1A, I will get in this way. So M1G into M2 plus M3 minus M1 divided by M1 plus M2 plus M3 plus M1G. Plus M1G. Okay, so M1G I can take common. I will be left with M2 plus M3 minus M1 divided by M1 plus M2 plus M3 plus 1. Okay, so I will get M1G M2 plus M3 minus M1 plus M1 plus M2 plus M3 divided by M1 plus M2 plus M3. So let us see what are the things that are getting cancelled. M1 and M1 will be cancelled. Okay, M1 and M1 will be cancelled. Fine. Okay. So I will be left with 2M2 plus 2M3. Okay, 2M2 plus 2M3. So 2 I can take common. So I can write 2M1G M2 plus M3 divided by M1 plus M2 plus M3. This is your T1. This is your T1. Okay. If I want to find out T2, so I hope you have understood up to this much. Okay. If I want to find out T2, so T2 also we can find out in this way where I am doing. So if I want to find out T2, so T2 will be equals to M3G minus M3A. So M3A, so I can write like this, M3G M2 plus M3 minus M1 divided by M1 plus M2 plus M3. Okay. Now we have to solve this. Okay. So this one is no longer needed. So this one I am rubbing. This one I am rubbing. This also I am rubbing. Okay. So M3G I can take common. So 1 minus M2 plus M3 minus M1 divided by M1 plus M2 plus M3. So M3G, M1 plus M2 plus M3, if I do the LCM, minus M2 minus M3 plus M1 divided by M1 plus M2 plus M3. Okay, let's see what are the terms that are getting cancelled. M2, M2, M3, M3. So here we are left with 2M1. Okay, so 2M1. So P2 is going to be 2M1 M3G divided by M1 plus M2 plus M3. This is your T2. 2M1 M3G divided by M1 plus M2 plus M3. Fine. So this is how you can find out everything. You can find out the acceleration, you can find out the tensions also. Just have to understand the concept. You have to understand the concept of free body diagrams. Okay. So this is how you can solve if 3 bodies are connected with the pulley and 2 strings are connected. Okay? Remember, this string and this string, they are different. Okay. One more thing we are going to do now, that is if 2 bodies are connected, okay, if 2 bodies are connected with a string which is passing over a pulley, but the 2 bodies are placed on a table. Okay, the 2 bodies are placed on a table. So now I am writing this one, number 4. 2 bodies connected, let us see. 2 bodies connected by a string. 2 bodies connected by a string. Okay, and 1 body, okay, passing over a pulley. And 1 body is placed on a smooth table. Okay, smooth table. Smooth means you have to understand. Whenever the word smooth is given, you have to understand I am talking about a frictionless surface. Okay, a frictionless surface. So this is suppose the table. Here there is 1 pulley. Over here there is 1 body. Here the string is going over the pulley and it is coming down in this way. And here I have connected 1 block. Okay. Remember, this is very, very important. And in many cases in JEE or NEET, you will see that this particular type of sum is given, but they have also given included friction. So if friction is included, then this sum will be little bit, few more steps. Okay, but easily you can solve. Afterwards, I will make some other video where I will tell you how to solve this type of things using friction. Okay, but for now, I am not considering friction. So this is your 1 body M1. This is your another body M2. Now let us see what are the forces that are acting. First of all, let us see what will be the motion of this body. So this body is placed on the table. Now if I consider that this is smooth, if I consider that this table is perfectly smooth, okay, this table is perfectly smooth, there is no friction, then of course this body is going to slide in this direction, because this one is going to fall in this direction with acceleration, and this body is also going to go in this direction with an acceleration. But if this surface has a friction, then that might not be the case. Suppose this force is acting, this body is trying to pull this block in this direction, but the friction is stopping the motion. That can happen. But if I consider no friction, that is, the table is absolutely smooth, then once this body, I have connected this body is going to come down and this body is going to slide down in this direction. So this acceleration A, this will also be acceleration A. Okay. But let us mark the forces. Over here, one force will be M1G. Here there will be tension. Of course, this pulley is pulling up this body. This pulley is also holding this body, so tension will be in this direction also. Here will be M2G, here will be R. These are the forces. We have to find out the acceleration of the bodies. So let us see for M1. So if you want to draw it separately, I'm showing you separately. This is your first body, M1. Always my advice is always understand the concept and draw the diagrams separately. Draw the free bodies separately. Always practice. Whenever you are practicing, always practicing this way, because you will be able to learn the concept much more better if you are learning it this way. M2. So M2 was in the surface. M2. One force is acting in this direction, that is T. Acceleration is in this direction. This is your M2G and this is your R. Okay. Let us see for M1. For M1. Okay. M1G and T. The resultant force will be M1G minus T. Because the body is moving in this downward direction, so M1G minus T, that is equal to M1A. So M1G minus T, that is equals to our M1A. So from here I can find out T will be equals to M1G minus M1A. Equation 1. For M2. Now see, for M2, first we have the vertical forces, but we know that vertically the body is not moving. Vertically the body is not moving, so these two forces are balancing each other. So I can write R equals to M2G. Okay. In the horizontal direction there is only one force, that is T, and T will be equals to mass into acceleration. Mass into acceleration. Now very easy to solve. Just put this value of T over here. Okay. So just put this value of T over here. So I will get M2A will be equals to M1G minus M1A. Okay. So M1A plus M2A will be equals to M1G. So M1 plus M2 will be equals to M1G. So A will be equals to M1G divided by M1 plus M2. This will be the acceleration of both the bodies. If I want to find out tension, we can easily find from here. So tension will be equals to M1 into divided by M1 plus M2 into G. This will be your tension. Okay, so this will be the acceleration and this is going to be the tension. So this is how we can solve this type of problem. Okay, some other type of problems are also there, which I will make a separate video. Suppose if one table is there, one block is over here and two pulleys are here. Suppose if two pulleys are here, like this, two pulleys are here. Now see students, in free body diagrams there can be many cases. There can be so many cases. There can be different cases. In the exams you might not even get common. The examiner might give some other case, some different case. The main thing is to understand the concept. Once you understand the concept, okay, what is the concept, how to solve, which force is acting in which direction, which will be the direction of the acceleration. Once you understand the concept, then any numerical if I give to you, you can easily solve. Okay, so this video will be up to this much. If you like the video, please like and subscribe. Thank you.